Your coding agent understands the bug, proposes the correct fix, and still fails. It ran the test from the wrong directory. That tiny mistake exposes the biggest weakness in many agent systems. Tool execution. An agent is not just a model. It is a loop connecting reasoning to an environment. Plan. Choose a tool. Construct arguments. Execute. Observe the result. Decide what happens next. Break any link in a capable model can look incompetent. Anthropic has described a concrete example. Agents making mistakes with relative file paths after moving away from the repository root. The reasoning can be fine. The environment state is not. Failure 1 is an ambiguous tool. Suppose a tool is named run. Does it run a shell command, a test target, a deployment, or a workflow? The model must infer behavior from a vague description and hope the dangerous interpretation is not feeling energetic. Use narrow names and explicit schemas. Run tests should accept a project root, test selector, timeout, and environment profile. Its description should state what it executes, what it cannot execute, and what a successful result contains. Failure 2 is hidden state. Current directory, active branch, environment variables, open transactions, logged-in account, and selected cloud project can all change a command's meaning, make important state visible in the tool input or observation. Prefer absolute workspace paths. Return the effective working directory and revision with every code-changing operation. A tool that depends on invisible history is teaching the model a guessing game. Failure 3 is noisy output. A build produces 10,000 lines. The important error appears once, and the agent receives the whole concert. Return a structured summary, exit status, failed command, relevant diagnostic, affected file, and a path to the full log. Keep raw evidence available, but do not force the model to reread every progress line on every turn. This is context engineering. The goal is not minimum output. It is maximum useful signal per token. Failure 4 is an observation that lies by omission. A command exits 0 but silently skips tests because dependencies are missing. A formatter reports success but changed no files because it ran in the wrong package. A deployment command returns accepted while the service fails later. Design observations around the real state transition. For tests, report discovered count, executed count, failures, and skipped reasons. For edits, report the diff and file hashes. For deployments, report the final health check, not only request acceptance. Failure 5 is unsafe retry. The agent times out and repeats the last action. Repeating a file read is harmless. Repeating a payment, email, migration, or package publication may duplicate consequences. Classify tools as read-only, idempotent, reversible, or sensitive. Attach an operation identifier so repeated requests can be recognized. Make sensitive retries stop for review. Now watch one coding task through the improved loop. The agent must fix a parser bug in a monorepo. It calls repository search with the root revision and exact symbol. The tool returns 5 matches with paths and short surrounding context. It opens the parser and related tests. It proposes a failing regression case. The test tool runs from an explicit package directory and reports that one selected test was discovered, executed, and failed with the expected assertion. The edit tool applies a patch and returns the exact diff. The test reruns using the same environment and passes. Then the agent runs the package suite. If unrelated tests fail, the observation separates pre-existing failures from new failures by comparing the baseline receipt. The model did not become smarter during this example. The tools became harder to misunderstand. Recovery also needs a contract, return typed errors, permission denied, invalid arguments, timeout, dependency missing, conflict, or target not found. Include the next safe action when it is deterministic. Do not translate every failure into something went wrong. The software equivalent of smoke coming from a locked room. Set budgets. Limit tool calls, elapsed time, output size, and repeated failures. If the agent invokes the same failing command 3 times without changing the state, stop the loop and surface the trace. Version tool contracts as carefully as APIs. If a search tool changes from returning paths to returning snippets, old prompts may assume the wrong observation shape. Add contract tests, valid input, missing target, permission denial, timeout, oversized output, and an attempted path escape. Run the same contract suite against every environment. The tool is production infrastructure even when its only customer is a model. Design a small golden trace for each important tool. A repository search should start from a fixed tree and return the same ranked matches. A patch tool should reject edits outside the workspace. A test tool should distinguish 0 tests from success. These examples teach both developers and the agent what correct interaction looks like. Then instrument the boundary. For every tool call, record the model task tool name, normalized arguments, visible state, duration, result type, retry count, and next decision. Redact secrets but preserve enough evidence to reconstruct failure. Classify each unsuccessful run. Was the plan wrong? Was the correct tool unavailable? Was the wrong tool selected? Were arguments invalid? Did execution fail? Was the observation misleading? Did verification fail to catch a defect? Only the first category is clearly solved by better reasoning. The others may need engineering. This prevents model shopping from becoming a debugging ritual. Before replacing the model, replay failed traces with corrected tools. If several models fail at the same boundary, the interface is the suspect. If one model consistently selects or interprets tools better under the same contract, then model choice is evidence-based. Coding agents operate through files, terminals, tests, browsers, and APIs. Their intelligence reaches reality through tools. A narrow, observable, recoverable tool contract can make an existing model dramatically more useful. A vague tool can turn a frontier model into someone repeatedly typing install from the wrong folder. When an agent fails, inspect the boundary before blaming the